99% of all freshwater ice on Earth is found above Greenland and Antarctica, and every year, a little of it melts into the ocean, according to Russia Today. Normally, it takes hundreds to thousands of years for all of the ice to melt, but what if an emergency happened that caused a massive global melt overnight? If this happens, while we sleep, sea levels will rise by 66 meters, as coastal cities such as New York, Shanghai and London will be submerged by a terrible flood, forcing up to 40% of the world's population to move out of their homes. As the chaos spreads across the land, high-altitude salt water seeps into groundwater reserves in the interior, making its way into nearby freshwater aquifers. Moreover, the ice in Greenland and Antarctica is made of fresh water, so melting it represents about 69% of the world's fresh water supply, which goes directly to the oceans, and this will wreak havoc on ocean currents and weather patterns. For example, a strong ocean current transports warm air to northern Europe, and it depends on dense salt water from the Arctic to operate. But a freshwater flood would dilute the current and might weaken it or even stop it completely. Without this warm air, temperatures in northern Europe would plummet, and a mini ice age could result, according to some experts. Himalayan glaciers pose one of the biggest threats because of the toxic chemicals trapped inside, and scientists have discovered that glaciers like these can store chemicals for decades, but as the ice melts, those rivers release the chemicals into rivers, lakes and groundwater stores, poisoning them. Each of them, arguably one of the most pressing problems with thawing permafrost, is mercury poisoning, and rightly so. There is an estimated 15 million gallons of mercury stored in the permafrost region, roughly equal to the amount of mercury anywhere else on Earth. Melting could cause global temperatures to rise by 3.5 degrees Celsius compared to today, and rivers and lakes around the world could evaporate, creating major droughts and desert-like climates. The additional water vapor in the atmosphere will fuel more frequent and stronger storms, floods and hurricanes, and there will be mass migrations to Canada, Alaska, the Arctic and even what remains of the Antarctic.